Good day, viewers. Welcome to another mathematics presentation. This is your presenter, Mr. Mrenga. So I want us to look at 2017 mathematics paper 1. This was for internal candidates. So I'm going to answer questions from 1 up to 23 with clear explanations and more detailed answers. So let's see how we can answer these questions. Alright, so we now come to question 1. Simplify 3x minus y minus 2x minus 3y. So in order for us to simplify this question, step 1, let us open the brackets. So you write 3x. So the way you can open the brackets is to multiply with this negative which is outside. So negative times y to be negative y. The negative times the negative 2x inside it to be a positive 2x. Then minus 3y. So from here, we can correct the like terms, of which the like terms are 3x and positive 2x, also negative y and negative 3y. So you correct these like terms, 3x, its like term it's a positive 2x. Then we write minus y minus 3y. So from here, 3x plus 2x, this will give us a 5x. So same signs, minus minus, we maintain the sign. So y plus 3y, this will be a 4y. So negative y minus 3y, the answer is a negative 4y. So this is our answer. Alright, so we come to our question 2. They want us to evaluate 81 over 16 raised to the power of a negative 1 over 4, then plus 81 over 16 raised to the power of 0. So first thing, we have to take note of the first one, which we have, there is a negative power. So if you have something like this, a over b raised to the power of, let's just say negative 1. So you have to make sure to get rid of the negative there by finding the reciprocal of the base. Okay, so the base is a over b, so the reciprocal will be b over a, like this, then to maintain a positive power. Okay, so similarly, if you have 81 over 16 raised to the power of negative 1 over 4, the way we are going to rewrite this, we will find the reciprocal of the base, which is 81 over 16. So we have 16 over 81, okay, then to the power 1 over a 4, then plus, so this one, it's 81 over 16 raised to the power of 0. So here, since it's raised to the power of 0, it's going to be a 1, okay, one of the laws of indices. Then from there, we can now apply, since it's 1 over 4, this 4 is the root, okay, meaning fourth root of both 16 and 84. So we can write something like this. We can write the fourth root of 16 over 81, okay, then raise the power of a 1. So this 4 is the fourth root, this 4, this is the root, okay, then this one will be the exponent or the power, okay. So we say plus 1. So what is the fourth root of 16? What number can we multiply by itself to get 16? So if you multiply 2 times 2 times 2 times 2, this will give us a 16. So the fourth root of 16 is a 2, okay. Then 81, what number can we multiply by itself 4 times to get 81? 3 times 3 times 3 times 3, this will give us 81. So the fourth root of 81, it's a 3, then plus 1. So from here, this is a fraction, this is not a fraction, we can divide by 1. Then we find the common denominator, which is a 3. So we are going to say 3 into 3, it's 1. 1 times 2, it's a 2, plus 1 into 3, it's a 3. 3 times 1, it's a 3. So this will give us 2 plus 3, it's a 5 over a 3. This is your answer, or you can leave it as a mixed fraction. 3 into 5, it's 1. Remainder 2 over a 3. So this is our answer. All right, so we now come to question 3. Question 3 reads, the gradient of the line joining the points are -2. So these are the points -2, k, and k, -14 is 2. So the gradient of these two lines is a 2. Calculate the value of k. So how can you find the value of k? Since they are talking about gradient, we are going to assume that we are finding the gradient, of which our formula for gradient is m is equal to, you say y2 minus y1 over x2 minus x1. So we need to rename our coordinates. So our coordinates, you say this is x1, then this is y1, this is x2, and this is y2. So when we organize our data right here, we have been given that the gradient of these two lines is a 2. So m is equal to 2, and the x2, we have renamed our coordinates. X2 is a k, then x1 is also a k, then y2 is a -14, and y1 is y1 it's a k. Then here I said x1 supposed to be a -2, like this. So we substitute in our formula. We are going to have m is equal to, so just we'll substitute. So you say where there is m, we'll put a 2 because the gradient is 2. M is equal to, what is our y2? It's a -14. Y1 it's a k over our x2, it's a k, minus our x1 is a -2. Okay, then from there we can see that on the right hand side you have a fraction. Even on the left hand side you can divide by 1, then we cross multiply, so that we get something like this. 2 will be multiplied with k. So here we can multiply negative and negative, which will be a +2, then equal to 1 times -14 to be -14 minus k. So this will give us 2 times k to be 2k, 2 times +2 to be a 4, equal to -14 minus a k. From here we can correct the like terms, of which we have 2k. The like term is a -k right here. So this will go to the left hand side to be a +k. It was a -k this side, then equal to -14 minus a 4. So this 4 was a positive. When it goes to the right hand side, it becomes a negative. From here, 2k plus k to be a 3k, equal to -14 minus 4. We maintain the same sign, then we add 14 plus 4, which will be 18, meaning -14 minus 4 is -18. So I want to find the value of k. So we need to divide by 3. Even this side we divide by 3. So we are going to get, we will cancel 3 and 3 out. K equal to 3a1, 3 into 18. So there is a negative here, it's a 6. So the value of k is a -6. We now come to question 4. Factorize completely. We have a x squared y minus 4ay power 3. So they want us to factorize. So we have ax squared y minus 4ay power 3. So the common letters, we have a, also y, y. So we are going to factor out letter a, and we are going to factor out y. Okay, so when we factor out this, we'll start now dividing. So our first term is ax power 2y, which will be divided by the letters that we have factored out. So this and this will cancel. This one and this one will cancel. we remain with x squared. So inside the brackets, we are going to write x squared such that when you multiply ay times x squared to give you ax squared y. So minus, we do the same with 4ay power 3. We divide by ay. So here, when we do the cancellation, a and a, so we have 4. So here we have y power 3. So when we get rid of 1y, we remain with y power 2. So we remain with 4y squared. So here we write 4y squared. Okay. So apart from that now, we write ay, pen bracket, x squared minus. So this 4 is a perfect square, which will be written as 2 to the power 2, and then y to the power 2. Okay. So from here, since now inside the brackets, we have the difference of two squares. We can see the square x squared, 2 squared, y squared. Then there's a difference, a minus there. So we are going to write now a final answer, which will be written as ay. Okay. Then I'll put the square bracket here. I'll write x minus 2y. I cross, again I open, x plus 2y. Okay, we close square brackets. So this is our answer. We have factorized completely. Alright, so we now come to question 5. Question 5 reads, the points P and Q have coordinates 2, 4 and negative 3, 1 respectively. So this is point P, this is point Q. Express PQ as a column vector. So they want us to express PQ as a column vector. So let me just illustrate with a diagram. So if you have the origin P there, or origin O, then we have P, then we have Q right here. So from the origin going to P, we have 2, 4. So I've written them in column form, okay, or in position vector. Then from OQ, from the origin O to Q, we are going to have these 3 and the 1. So they want us to find this side now, PQ. So here is just the movement. We'll move from P coming to O, which is PO, okay? Then plus, again from O to Q, which is OQ. So here we have said you are going to move PO plus OQ. So what you do now is, you can see this direction for PO, it's against the direction, okay? So it's going to have a negative. So you take now the vector column form, which is 2, 4, plus for OQ it's a negative 3 and the 1. So what you do is you multiply negative times 2, which is a negative 2, negative times 4, a negative 4, like this. Then we add with the negative 3 and the 1. Okay. Alright, so from here it's just a matter of adding. We'll say PQ equal to, so you add negative 2 plus negative 3. So negative 2 plus negative 3, this will give us a negative 5. Then we also add negative 4 plus 1. This will give us a negative 3. So this will be the column vector PQ. Okay, so we have answered our question 5. We now move on to next question. Alright, so we now come to our question 6 right here. Shade. So they want us to shade B complement intersection A intersection C. So you can shade directly. Okay, now for the sake of those who want to know, you can do this. First thing, come up with elements in these sets so that they help you to identify the area that you are going to shade. So let's say I write 1, 2, 3, 4, 5, 6, 7, 8. So I'll start by finding A intersection B. So my A intersection C, sorry, equal to, so it will be A intersection C. to be 5 and 4, 4 and 5. Okay, then apart from this, I'll come up with a set B. So we know that our set B is 2, 3, 5, 6. This will be our set B. So from here now we can say, therefore we'll say B complement. So B complement means the elements that you are going to write in this set should not be part of, we exclude all the elements for set B. So when we exclude 2, 3, 5, 6, the elements that we are remaining with are 1, 4, 6, 8. This is the B complement. So we write 1, 4, 7, 8. Alright, so therefore, we can say now, therefore, B complement intersection, then we have A intersection C. So B complement intersection A intersection C. So A intersection C, it's this, then the B complement is this. So we need to find the intersection of these, B complement and A intersection C. What is common? So you can see that in B complement we have a 1, okay, but in A intersection C we don't have a 1. We have a 4 right here, and here there is a 4. So 4 is intersecting, you write a 4. Apart from a 4, we have a 7, but in A intersection C there is no 7. Then we also have what? 8. And here there is no 8. So the only element that is intersecting, it's a 4. So we are going to shade on the area where we have a 4. Alright, so when you look at the diagram, the 4 is right here. So this is the part that you are going to shade. Okay, just this part. So I hope you have gotten what I've explained. So to those who know how to answer it direct, you can do the same, it's fine. But I was doing this for the sake of those who didn't know. So this is B complement intersection in brackets A intersection C. Okay, this is our answer. Alright, so let us now look at our question B right here. I want us to express matrix AB as a single matrix. So AB means matrix A times matrix B. So we are going to write AB equal to, where there is A, we put a matrix for A, which is a 3, 2, 1, 4, 3, 0. So this is multiplied with the matrix for B, which is 1, 2, 3, 3, 2, 1, 0, 1, 0. Okay, this is what you have. So how can we multiply this? Alright, so the way we are going to multiply this, you say this row times this column. This will give us the first entry. Again, the same row times the second column. Again, the same row times the third column. When we are done, then that's when you come to the bottom row. So I'm going to say AB equal to, allow me just to write something big. So we have 3 times 1, which is a 3, plus 2 times 3, which is a 6, plus 1 times a 0, which is a 0. So this is our first entry. I'll leave space. Again, I'll say row times column. So this 3 times the 2 right here, it's a 6. Again, 2 times 2, so it's a 4. I'll say plus 4. 1 times 1, it's a 1. So I'll say plus 1. Again, I'll leave space. The same row times the last column. So 3 times 3, this will be a 9, plus 2 times this one, it's a 2, plus 1 times a 0, it's a 0. we can cross. We are done. So we now come to the second one. Okay, so for the second one, we do the same. Row times column, first column, second column, third column. So we are going to have this 4 times a 1, it's a 4, plus 3 times 3, it's a 9, plus 0 times 0, it's a 0. We are done. We leave space. Again, 4 times a 2, it's 8, plus 3 times a 2 right here, it's a 6, plus 0 times a 1 right here, it's a 0. We are done. We go to the last column, row times column. 4 times a 3, it's a 12, plus 3 times 1, it's a 3, plus 0 times 0, it's 0. Okay, so this is how you do it. Okay, so from here we can have something like this. Now we say AB equal to, so 3 plus 6 plus 0, you get a 9. 6 plus 4 plus 1, you get 11. 9 plus 2, you also get 11. Okay, we can cross. Then here 9 plus 4 will get 13. Then plus 0 is still 13. 8 plus 6, you get 14. Then 12 plus 3, you get a 15. So this is our answer. We have found, or we have expressed matrix AB as a column matrix. Okay, so we now come to question 8. For the sequence 25, 22, 19, 16, find the, so they want us to find the formula for the nth term. So how do we find the formula for the nth term? So you say nth term is equal to a plus, open bracket, n minus 1 cross d. So we need to know the value that is presenting a. Okay, so is the first term. The first term here is a 25. And then d is the common difference. So the common difference is found by subtracting term 2 minus term 1. So in this case, this is our term 1, this is our term 2, this is our term 3, and this is our term 4. So if you want, you can say term 3 minus term 2 or term 4 minus term 3. You get the same value. So term 2 is a 22, then term 1 is a 25. So the common difference will be a negative 3. Okay, so we can substitute where we have a. So right where we have a, we'll put 25, plus where we have n, we'll leave it the way it is because it's the nth term we are finding, minus 1, times where there is d, we'll put the negative 3. Then from here, we will say 25, then negative 3 times n to be negative 3n, negative 3 times negative 1 to be a positive 3. From here, we can correct the right terms, where we say 25 plus 3 minus 3n. So this will give us 28 minus 3n. So this is the nth term. Okay. All right. So let us now move on to question B. Find the sum of the first 20 terms. All right. So we now find the sum of the first 20 terms. So our formula will be sum of first 20 terms is equal to n over 2. This is the formula. Open square bracket 2a plus, in brackets we have n minus 1, then times the common difference. So we need to come up with our data. So in our data, a is the first term, which is a 25. Then in the common difference, we said this is a negative 3. Then what will be the value of n? It will be a 20 because they have said sum of the first 20 terms. Okay, so we just substitute where there is n, we put a 20 over a 2, pen square bracket 2 times where there is this a, you put 25, which is the first term, then plus where there is n, you put a 20 minus 1 times where there is d, we put a negative 3. Then we cross like this. From here we can say 2 here 1, 2 into 20, it's a 10. So we can have 2 times 25, it's a 50, plus 20 minus 1, it's a 19, which will be multiplied with a negative 3. Okay. Alright, so from here we need to open the brackets. So I write 10, open square bracket 50 plus, okay, let me do this. So we need to open the brackets by multiplying this 19 times a negative 3 right here. So this will give us a negative 57. Yes, to give us negative 57. Then from here we can say 10, open square bracket, 50 minus 57. This will give us a negative 7. Okay, so from here we can say our final answer now. Let me write it here. Therefore, the sum of the first 20 terms is equal to, so just multiply 10 times a negative 7, which will give us a negative 70. So this was the sum of the first 20 terms, which is a negative 70. So I have answered this question. Let us now move on to our next question. Alright, so we come to question 9 now. Town L is only 0 degrees, 30 degrees west, and town K is only 0 degrees, 60 degrees east, as shown in the diagram below. So town L and K, they are lying on the same latitude, which is 0 degrees, which is the equator. So question A, here is our question A. If a radio quiz is scheduled to start at 12 hours at L, okay, find the time at which the people at K will be listening to the quiz. So what will be, if the people at L, the radio quiz will start at 12 hours. What about people at K? Okay, so what you need to do is you need to find the time difference. Okay, so come up with TD. TD means time difference is equal to difference in longitudes. This is our formula, divided by 15 degrees. Now, where is the 15 degrees coming from? We understand that for per every 24 hours, the Earth rotates at 360 degrees. So per hour, okay, the Earth will rotate at 15 degrees, meaning that we just divide 360 divided by 24 hours, which will mean that per 1 hour, the Earth will rotate at 15 degrees. So we need now to find the difference in longitudes. So point L is on longitude 30 and point K is on longitude 60. So the difference in longitude, since they are lying on different hemispheres, this one on west and this one on east, we need to add. So you say 60 plus 30. This will give us a 90 degrees. But if they were lying on same hemispheres like west, west, it should have subtracted, okay? Now they are on different hemispheres. West, east, north, south. We are supposed to do what? To add. That's why I've added. So say time difference equal to the difference in longitude. You have found that it's a 90 degrees divided by a 15 degrees. And this will give us, we just need to divide where we say 90 divided by a 15. Remember, this is a paper one, so there is no need for you to use a calculator. So time difference will be 06 hours. This is the time difference. Okay, it will be 06 hours. So looking at where point K is, it's lying on the longitude east right here. So on east side, it does gain what? It gain time. So we will say, therefore, we are just going to add. If the program will start at 12 hours, okay? If the program will start at 12 hours, to find the time that the program will start at k, we are going to add with the time difference that we have found, which is 06 hours. So when we add these two, we'll get 6, 7, 8, 1 plus 0, it's 1. So meaning that at point k, the program will start around 18 hours. Okay, this is how we can answer our question A right here. So this will start at 18 hours. Okay. All right, so we now come to question B. What is the distance between L and K in kilometers? So take radius of the earth to be 6370 and the pi to be 22/7. All right, so they want us to find the distance between point L and the point K, meaning that it's the distance along the line of what? Latitude, as you can see. So we need to come up with our formula, and our formula will be distance is equal to, so this is the distance along the line of what? Latitude, and the radius of the earth is in kilometers. So the formula will be theta divided by 360 degrees times 2 pi r cos x. Okay, so here we need to take note of something. We have been given that theta is the difference in latitude. So point K is lying on latitude 60 and the point L is lying on latitude 30. So on different hemispheres we add the theta is 90 degrees. Then x, okay, x is the latitude on which these 2 points are lying. So these 2 points are lying on latitude 0 degrees here, which is the equator. Okay, then the radius of the earth you have been given that it should be 6370. The pi should be 20/7. So just substitute distance equal to 90 divided by 360 times 2 pi. We need to substitute. So you say times 2 times the pi is 22/7 times 6370 times cos 0 degrees. Okay, so from here we will proceed. We can say 90 then 90 into 360. It goes there exact times without giving you any remainder. Okay, which is it goes how many times there is a 4. So 1/4 times, so here we have 2 times 22/7 times 6370. So where we have cos 0, so cos 0 definitely it's a 1. Okay, so cos 0 gives us a 1. Cos 0 it's a 1. Okay, so it won't change anything. So from there we can now proceed. All right, so here we now need to work out something. Remember, this is paper 1, so we just say 2 here, it's a 1. 2 into 4, it's a 2. 7 here, it's a 1. 7 into 63, it's a 9. 7 into 70, it's a 10. So what you have remained with, you say d equal to 1/2, okay, times 22 times 910. Then from there we say d equal to, again 2 here 1, say 2 into 9, okay, it goes there many times, 4, remainder 1. So 2 into 11, it's a 5, remainder 1. 2 into 10, it's a 5. So we are remaining with 22 times 455. So we need to multiply this 455, okay, times 22. So no need of using a calculator. 2 times 5 is 10. 2 times 5 is 10 plus 1, 11. 2 times 4 it's 8 plus 1, 9. Then 2 times 5 is 10. 2 times 5 is 10. So 11. 2 times 4, 8 plus 1, 9. So just put the zeros here. We maintain the place value. So 0 plus 0, 0. 1 plus 0, 1. 9 plus 1 is 10. So I write a 0. 0 plus 9, it's a 9. Plus that one, it's a 10. We'll get something like this. Then the units were in kilometers. So this was the distance. Alright, so the distance between town. So you just say therefore distance between L and K equal to 10010 kilometers. Alright, so which is very, very easy to answer. We now move on to our next question. Alright, so we come now to question 10 right here. So under question 10, we have A and B. We are going to start with question A. The probability that Chakupaleza will go for remedial lessons on a particular day is 7 out of 10. What is the probability that she will not go for her remedial lessons on that particular day? So the probability that we will go, probability that you attend lessons, okay, then plus the probability that she will not attend, okay, at the probability that you not attend, okay, is equal to 1. So the probability that you attend lessons, you have been told that it's 7 over 10. So where there is this, we'll put 7 over 10 plus the probability that you will not attend is what we want, okay, plus probability that she will not attend, okay, equal to 1. So this 7 over 10 will go there, okay. So when 7 over 10 goes there, you are going to have something like this. Probability that we will not attend, I'll just write not, is equal to 1 minus 7 over 10. So we divide by 1. Common denominator, it's a 10. So 1 times 10, 10 minus 7. Meaning 1 into 10, it's 10. 10 times 1 is 10. 10 into 10 is 10. 10 times 7 is 10. So 7 times 10, 10 minus 7, it's a 3 over 10. So this is the probability that Chakupareza will not go for remedial lessons on that particular day, which is 3 over 7. Alright, so we now come to our question B right here. Solve the equation. So the equation is 10 raised to the power of x is equal to 0.0001. So how can we solve this? Equation? So step 1, we write 10 raised to the power of x is equal to. So here we look at the place value of this 1. So the first one, this 0, it's 10th, 100th, 1000th, 10,000th. So meaning that you are going to write 1 over 10,000. You write it as a fraction, looking at the place value of 1. Okay, it's 10,000th. Okay, 10,000th. So it will be 1 over 10,000. So upon writing this, then we can change this 1 over 10,000 as 10,000 to the power negative 1. Okay, why are we writing that? You remember under the laws of indices, if you have something like this, 1 over 10, for example, this can be written as 10 to the power negative 1. Or if you have, let's say, 1 over a, this can be written as a to the power negative 1. So it's the same principle that I'll use even here. So I'll write 10 to the power x is equal to 10,000 to the power negative 1. Okay, why are we writing this? You want to make sure that on the left hand side and the right hand side, we are going to have the same bases. Okay, all right, so from here now we are going to do this. So you write 10 to the power x equal to 10. Okay, 10 to the power 4. Okay, then this will be raised to the power of a negative 1. Now, why have I written 10 to the power 4? So 10,000, remember here the base is 10. So even this 10,000, it's a perfect square number, which can be written as 10 to the power 4, meaning that if you multiply 10 to the power 4 by itself 4 times to give you 10,000. So that's why I've written 10 to the power 4. Then you put it in brackets with the power of a negative 1 because of this negative 1 right here. So we'll just say 10 to the power x is equal to 10 to the power negative 4. So here we have just applied one of the laws of indices, which is power of power. If you have a over b, okay, a over b raise the power of 2, again maybe raise the power of a 3. So you can just multiply this and this. So here I've just multiplied the 4 and the negative 1. So the bases are the same. So if the bases are the same, we can also equate the powers are the same. So therefore x is equal to negative what? 4. So here it's x is equal to negative 4. This was the value of x. Alright, so we come now to question 11. So under question 11 we have a and b. So we are going to start with question a. Given that the inverse set is equal to 2, 4, 6, 8, 10, 12, set A, so I'll write our set A, which is equal to 4, 8, and 12. Then we also have our set B. So our set B is 2, 10, and 12. Okay, so they want us to find A complement intersection B. So A complement first, let's find A complement. So A complement means the elements that are in set A should not be part of the solution set for set A complement. So we cancel 4 from the inverse set, 8, 8, 12, 12. So the remaining elements, that is A complement, which is we are remaining with a 2, 6, 10. Okay, then from there we can say let's find A complement intersection B. So we say A complement intersection B equal to, so this is our set B and this is our set A complement. So what is common? We have 2. 2 is common. What else? A 10 is common. Okay, in set B there is a 12, but here there is no 12. So this is set A complement intersection B, 2, 10. We have answered this one. Let us now move on to question B right here. Alright, so we now come to question B. The diagram is a sector with center O and radius 7 centimeter. Angle at O is 270. So this is a sector that we are given. Calculate the area of the sector. Take pi to be 20 over 7. So area of the sector is given by this formula. Theta divided by 360 degrees times pi r squared. Okay, so here we say area equal to the theta is this angle right here, which is a 270 degrees over a 360 degrees times The pi, we have been told that is 22 over 7 times radius, because it's r squared. Okay, so from there, we are going to say area equal to, we can cancel this 0 and this 0. We have 27 over 36 times this 7 and this 7, 22 times 7. So from there, we can do this. We'll write area equal to, so what number can go into 27 and 36? The highest common factor. 9 here, it's a 3. 9 into 36, it's a 4. So we have 3 over 4 times 22 times 7. So area equal to, we say 2 here, it's a 2. 2 into 22, it's 11. So we have 3 times 11 times 7. Okay, so this will give us, say, area. So 3 over 2, yeah, 3 over 2. So this will give us, we say 3 times 11 to be 33, then times 7 over 2. Area equal to, so we can try to do this. We say 2 into 3, it's 1, remainder 1. 2 into 13, it's 6, remainder 1. 2 into 1, it can't, so we put a point. 2 into 10, it's a 5. So 16.5 times 7. Area equal to, so you just need to multiply this 16.5 times 7. Okay. So 7 times 5, this will give us a 35. You write 5, we carry a 3. Then next, we just have to multiply 7 times 6. I think this will give us a 42. 7 times 6. So here we put a point. Write a 2. Wanted to write a 4. Since we have said the 42, so it should give us write a 2 here. Sorry for that. Before I write a 2, we are carrying a 3 there. Yeah, we are carrying a 3. So 42 plus 3 to be 45. So I write a 5. We carry a 4. 7 times 1, it's 7, plus 4, it's 11. Okay, so this means 16.5 times 7. This will give us 115.5. So the units were centimeter square. This is our area. So make sure that you calculate nicely. This is paper 1. There's no need for you to use a calculator. Alright, so we now come to question 12 right here. The function f and g are defined by fx is equal to 2x plus 1 and gx is equal to 5x minus 1. Find g inverse of x. So to find the g inverse of x, first we are going to take note of the function for g x, which is 5x minus 1. So to find the g inverse of x, we will introduce a y, then you say 5x minus 1. Then from here, we need to make x the subject of the formula. So this y will be added by 1, then plus 5x. So from here, we can divide by 5, even this side by 5. So this 5 and this 5 will cancel. Therefore, x is equal to y plus 1 over a 5. So we can say, therefore, g inverse of x equal to, where there is a y, we put x plus 1 over a 5. This is the answer for our first question A. So let us now look at our question B, which is right here. All right, so we've now come to question B, where they want us to find the fg of x. So this is a composite function. So for this composite function, it means that the function of g is composing the function of what? T? F. That's what it means. So on the function of f, we are going to put the function of g. So the function of fx is 2x plus 1, and the function of gx is 5x minus 1. So to find fgx, I've said this function of g will compose the function of what? F. So I write the function of f, which is 2x plus 1. So on this function of f, where there is x, we are going to put the function of g. So we say 2, the function of g is a 5x minus 1, then plus 1. So I've just replaced on x right here. So from here, we can open the brackets by multiplying with a 2. So 2 times 5x, 10x. 2 times negative 1 is a negative 2, then plus 1. So from here, we can proceed. You can simplify this. You are going to have 10x, negative 2 plus 1. This will be negative 1. So this will be the function of gx, okay, which is 10x minus c minus 1. So let us now answer question C right there. So question C, they are saying find function of g of negative 3, fg of negative 3. So remember your function, I found the function of fg, which is this one. So just say function of g, negative 3 is equal to, you write 10x minus 1. So where there is x, we'll put x is equal to a negative 3. So here we'll say 10, then bracket negative 3 minus 1. So this will give us 10 times negative 3 to give negative 30 minus 1. So negative 30 minus 1, this will give us negative 31. This is the answer. Okay, so here we are having a negative 31, and here it was 10x minus 10x minus 1. Yeah, 10x minus 1, I believe so. 10x minus 1. Then here I think, have I forgotten? It was x minus 1, x plus 1 over a 5. Yeah, anyway, you confirm if I've forgotten here. So we have answered our question 12. We will now go to our question 13. Alright guys, so we've now come to question 13. So under question 13, we have question A and B. So I'm going to start with question A. The kite in the diagram in the answer space has coordinates 0, 0, 2, 1, 5, 0, and 2, negative 1. Draw the image of the kite after a reflection in the line y equal to x. So first thing, you have to understand something concerning reflection. So reflection is a transformation in which any two corresponding points of the object and the image have the same distance. Okay, that is from and to at the right angles to a straight line that we call the mirror line. That is what reflection is. So let's take a look at the diagram. So this is our diagram. Okay, so they want us to draw the reflection of this object that we have. So how can we draw the reflection of this object? So first thing, they have given us the points, okay, or rather the coordinates. The first one they have said 0, 0. Then the second one they have said 2, 1. Then the third one they have said 5, 0. Okay, then lastly we also have 2, -1. Okay, I believe these are the coordinates. Let me just confirm for 2 comma -1. Yeah, it's 2 comma -1. Now, if you want to find the image or the reflection of this image that we have right here, okay, they have said it's passing through the mirror line. So where is the mirror line going to be? Remember, the mirror line, they have said it's y equal to what? X. This is the mirror line. So what we are going to have, the line is going to pass here, okay, right here. This is where we are going to have the mirror line. So this mirror line is y, okay. So this mirror line is y equal to what? To x, okay. So this is y equal to x. Now what it means is these coordinates that you have 0, 0, they will be just 0, 0. We start swapping them so that we find the reflection. Then for 2, 1 is going to be 1, 2. Then for 5, 0 is going to be 0, 5. Then these coordinates for 2, -1, when we swap them, it will be -1, 2. So let us just find the points. So when you come here, where we have, we start with this one, 0, 0 is on the same point, okay. Then 2, 1, the 2 is right here. Then the 1 is going to be here, 2, 1. It's going to be right here. Then we also have 0, 5, 0, 5. It will be right there on 5. Then we also have -1, 2. -1, 2. Yeah, I even plotted the wrong one. Yeah, it's going to be there. -5, -1, 2. Okay, so let's see which one have I left. 1, 2, 1, 2. Yeah, this is the one that was left. So we have another one right here on 0, 0. So these are the points. As you can see, we have this one for 0, 5. We also have this one for -1, 2. We also have this one for 0, 0. We also have this one for 1, 2. So let us just join these points. Okay, so when we join these points, we are going to have something like this. Okay, all right, so this is the image that you are going to have. This is our image, okay, and this is our object. So I hope we have seen how we have answered this question. So we are done answering question 3a. Let us now move on to question 3b. All right, so we've now come to our question 3b. So our question 3b reads, 13b. The question reads, differentiate y is equal to 1 over 3x power 3 minus 5x power 2 minus 2x with respect to x. So how can we differentiate this function? So first thing, we are going to write the function that we have. Y is equal to 1 over 3 x power 3 minus 5x power 2, then minus 2x. So step 2, we understand that if you have a function like y equal to ax power n, so to differentiate this, we can either use the formula method or the first principle. So we are going to use the formula method. So to differentiate this y with respect to x, we say dy dx equal to, so here the coefficient of x is a, so this a will be multiplied with the power n, so it's a times n, then x, the power n will be reduced by 1. So we are going to use this idea to apply it right here. Okay, so what you are going to say is, if we have we say dy dx equal to, so the coefficient of x power 3 is 1 over 3. So 1 over 3 times the power of x, which is a 3. Then we write x 3 minus 1. So the power 3 will be reduced by 1 minus the coefficient of this x power 2, it's a 5. Or you can say negative 5. I'll just write a 5 here, times the 2. Okay, then x power 2 minus 1. Then minus, then here we are going to have so this x right here, it means it has a power 1. So I'm going to say 2 times, okay, so 2 times, so the coefficient, the power of x there, I've said it's a 1. So it will be 2 times 1, then x power 1 minus 1. Now from here, when you multiply, you can cancel this 3 and this 3. You just remain with a 1. 1 times x is the same x. 3 minus 1 there, you remain with x power 2 minus 5 times 2, it's a 10, then x. Because here where we have 2 minus 1, 2 minus 1 remain with a 1. That's why I'm having x right here, of which the power 1, I can't show it, is fine. Then from there, we can say 2 times 1 right here, we'll get a 2. So here we are going to have minus 2. Okay, now here where we have x, so we have x, 1 minus 1 is a 0, so x power 0, which will give us a 1. So this one will be multiplied with the 2 that you get from here, of which will get the same answer. So this is our answer. Okay, dy dx is equal to x power 2 minus 10x minus a 2. So we have differentiated this function. So let us now move on to our next question. Alright, so we've now come to our question 14 right here. The question 14 reads, two boats x and y leave port P at the same time. X travels on a bearing of 159 degrees and y travels on a bearing of 215 degrees as shown in the diagram below. After some time, x and y are at points such that angle PYX is equal to 41 degrees. So this is the diagram right here, which is showing the two boats x and y. The question, find the bearing of x from y, the bearing of x from y. So where they are saying from y, you need to draw the north right here on y. Okay, so to draw our north on y, it's going to look like this. We are going to draw our north right here on y. So when we draw our north right there, they want us to find the bearing from x to y. This is the bearing that they want. So we need to find an angle that will be right here. When we find the angle which is right here and we add with the 41 that we have, that will be the bearing of x from y. So how can we find an angle which is right here? So first thing, you can see that right here we have the bearing of the point where y travels on the bearing of 215 degrees. So a complete angle now here adds up to 360. So this tells us that we need to find an angle which is right here. Okay, so how can we find this angle? Remember, I've said the complete angle is 360 degrees, then we subtract 215 degrees. So 0 minus 5, it can't. We borrow a 1. From 6, we have a 5. 10 minus 5, it's a 5. 5 minus 1, it's a 4. 3 minus 2, it's a 1. So we have a 145 degrees. So since we have 145 degrees here, we can use this angle to find the angle that will be right here. So you can see this is the same transverse line. So the angle which is right here 145 and the angle which is right here, these are called allied angles because they are lying on the same transversal line. So allied angles add up to 180. Okay, so what you are going to do to find this angle right here, we just subtract 180 minus 145. Then you remain with the angle that you are going to put there. So we are going to say 180 degrees minus 145 degrees. So 0 minus 5, it can't. We borrow a 1 from 8, we remain with 7. 10 minus 5 to give us a 5. 7 minus 4 to give us a 3. 1 minus 1 is a 0. So here we have a 35 degrees. So this means that here we had a 35 degrees. So now, remember, we want to find the bearing of x from y, the whole bearing right here. So I need to add 35 degrees plus 41 degrees. That means we have found the bearing of x from y. So we're just going to say, therefore, we'll add 35 degrees plus a 41 degrees, and this will give us 5 plus 1 is a 6, 3 plus 4, it's a 76 degrees. So here, the bearing of x from y, it was 0.76 degrees. So you need to leave it as a 3-figure bearing. So that is our answer for question A. Let us now answer question B. Alright, so we now come to our question B. Find the bearing of P from X, the bearing of P from X. So P from X, meaning that we need to come up with the north right here on X. So we do the same. So our north will be drawn from here, which will look like this. This will be our north. So this north, the bearing that they want us to find is all the way from this line until we reach this line for P. So this is the bearing that they want us to find. So in order for us to find this bearing, we need to find an angle which will be right here, a smaller angle which will be right here. Okay, so this smaller angle we need to find, it should be right here. Okay, so how can we find this angle? To find this angle, we are considering, remember we have a 159 degrees right here. So this angle which is here and this smaller angle right here, these are allied angles. They are on the same transverse. Okay, so allied angles, they add up to 180. So to find this smaller angle, we need to say 180 degrees minus 159 degrees. So 0 minus 9, it can't. We borrow a 1 from 8, we remain with a 7. 10 minus 9, it's a 1. Then 7 minus 5, it's a 2. 1 minus 1 is a 0. So the angle, the smaller angle right here, it will be a 21 degrees. The angle it will be right here, it's a 21 degrees. So how can we find now the bearing of P from X, this a bigger angle right here? So remember, this will be a complete angle which gives us 360. So we already have a 21 degrees right here. So to find this angle now from this north pole up to this line, we just need to subtract from 360. So say 360 minus a 21 degrees. So this will give us 0 minus 1, it can't. We borrow a 1 from 6, we remain with a 5. So here I have a 10 minus 1 to be a 9. 5 minus 2 to be a 3. 3 minus nothing, 3 minus 0, it's a 3. So this will give us 339 degrees. Okay, so these were the answers to this question. Let us now progress to question 15. Alright, so we now come to our question 15. The question reads, Misozi and Firamba estimated the length of a line to be 9 cm and 10 cm respectively. If the true length of the line was 9.6 cm, find A, Misozi's absolute error. So here we need to find the absolute error for Misozi. So to find the absolute error for Misozi, we are going to come up with our formula, which is absolute error is equal to, so this is our formula, recorded value. So we need to put the bars, and we say recorded value minus true value. So this is the formula for absolute error. Then we put a bar. So these bars that I've indicated here, this bar and this bar, they tell us that whenever if we find a negative value, it should give us an absolute value which is a positive. So we proceed. So from here we will say absolute error equal to, now what is our recorded value? So in this question they are saying if the true length of the line was 9.6, so this is the true value, 9.6 is the true value. So since we are looking at Misozi and Firamba, the first person is Misozi. So the recorded value for Misozi is the first number, which is 9, because Misozi is the first one. So where there is recorded value, put 9. Where there is true value, it's 9.6. So we are going to write recorded value. We have said this is a 9 minus the true value, it's a 9.6, like this. So from here, when you do the subtraction, 9 minus 9.6 to give us a negative 0.6. So I've said these bars will give us a positive value, which will be a 0.6. So this was the absolute error for Misozi. So let us now answer question B. Alright, so we now come to question B. Find Firamba's percentage error. So how do you find the percentage error? To find the percentage error, we also need to come up with a formula. So the formula for percentage error, it will be percentage error. I'm using the initials, P for percentage, E for error. Percentage error is equal to relative error. So relative error times 100%. So this is the formula. Now on this formula, first thing, you need to find the relative error. So how do you find the relative error? To find the relative error, you just say absolute error divided by true value. So whenever we find the absolute error divided by the true value, we need to multiply with this 100%. So from here, since we have absolute error here on top, we need to find this absolute error. So our absolute error equal to, so our formula, we said it's recorded value minus true value. So when you look at the question, we are finding for Firamba. So Firamba, the recorded value was a 10 right here. Okay, so we are going to do this. We are going to put a 10. So you say absolute error is equal to the recorded value. I've said it's a 10 minus the true value, it's a 9.6. So when we subtract, we are going to have absolute error equal to, so what is our recorded value 10 minus 9.6. This will give us 0.4. Okay, so this will be our absolute error. And then we come back to our question. So in our question, we will just fuse in and we will say here where there is absolute error, we will put, so let me just proceed from here. We will put 0.4 over what is the true value, 9.6, then times the 100%. Okay, now we need to get rid of the decimal point here, 0.4 divided by 9.6. So how do we get rid of these decimal points? We need to multiply by 100. So this will be by 10. Even this will be multiplied by 10. So we are going to have 0.4 times 10. We are going to have a 4 over a 96, then times 100%. So from here we can say 4 here it's a 1, 4 into 9 it's a 2, remainder 1, 4 into this 16 it will be a 4. So we have 1 over 24 times 100%. So we can do the same. We have 24 here and the 100, so we can divide by 4. 4 into 20, so 4 into 100 it's 25. Then 4 into 24 it's a 6. So we are going to get our answer as 25 over a 6%. This is Firamba's percentage error. Okay, so this is Firamba's percentage error. We have found it. So if you want, you can leave it as a mixed fraction or as a decimal number. You'll still be marked and you'll get your 2 marks. Alright guys, we now come to our question 16 right here. The question reads, it is given that t is equal to kv squared, where k is the constant of variation. So we have this table right here. We have v, t, here we have the values of v, and down here we have the values of t. Use the information given in the table to find the value of k. So we need to find the value of k using this, okay, this formula or this equation that have been given. So first thing, we take note of the equation. So the equation is t equal to kv squared. So how can we find the value of this k? To find the value of k, we are going to use the first values of v and t. So here we have a 1, here we have a t. So we are saying when we organize our data, the value of v is equal to 1 and the value of t is equal to 4, because these are the first values that you have here. So where there is t, we will replace with a 4 equal to k times, where there is v, we replace with a 1, which is 1 squared. So we are going to have 4 equal to k, okay, because 1 squared means 1 times 1, and you get 1. So this 1 times a k, you still get a k. So the value of k is equal to what? A 4. So we have answered our first question. Now, how can we find our second question? Find the value of a. So you can see the a is here. The corresponding value of v is a 5. So let us use the same equation. T is equal to kv squared. So here it means that the value of t, it's a that they want you to find, and the value of v, it's a 5, which is right here. And the value of k, we have found that it's a what? A 4. So we just need to substitute. Where there is a t, we put a equal to, where there is k, we put 4 times, where there is v, we put 5 times 5, because v is squared, so it's 5 times 5. So we're going to have A is equal to 4 times 5 times 5, it's 25. So A equal to 4 times 25, this will give us 100. So the value of A is equal to 100. Alright, so we now come to question C. Find the values of B. So they have said the values of B. So this tells us that we are going to have two possible values of B. So first thing, we take note of our equation, which is T equal to K V squared. So where is our B? This is where the B is, which is in the corresponding values of V. And here we have 36 in the corresponding values of what? T. So this means that T is equal to 36, okay? And V equal to B, and K, the constant of variation, it's a 4. So we just need to substitute. Where we have a T, we are going to put a 36 equal to, where we have the K, we are going to put a 4, okay? Then times V squared. So we need to find the value of V. So you need to divide by 4. Even this side we divide by 4. So this 4 and this 4 will cancel. V squared is equal to, so 4 into 36. 4 here 1. 4 into 36 goes there 9 times. 1 into 9, you get a 9. So this V is squared. So you need to get rid of the square by introducing the square root. Even this side is square root. So therefore, this 2 and the square will cancel. We are going to have V equal to plus or minus, what is the square root of 9? It's a 3. So our final answer will be V equals to positive 3 or V equal to negative 3. So these are the final answers. V is equal to 3 or V is equal to a negative 3. Okay, so we have answered our question 16. Let us now move on to our question 17. Alright guys, so we've come to question 17 right here. In the diagram below, A, B, C, D, E, and F are points on the circumference of a circle. FBD is equal to 70 and AEF is equal to 20. So this is the diagram that is showing the points A, B, C, D, E, and F, which are points on the circumference of a circle. So we have been told that angle FBD, right here we have a 70, and angle AEF, we have a 20 degrees right here. Our first question A, explain why AD is the diameter. So this line AD, why is it a diameter? Okay, so before we answer or before we explain why AD is a diameter, let's take a look at the triangle ACD. It's a triangle that is formed. Also, we take a look at the triangle ADE. Okay, we can see ADE F right here. We also have another triangle. So this diameter is cutting a circle into two equal parts. It's forming a semicircle. Okay, so when you look at the angle which is on E right here, it's a 20 degrees. Okay, angles in the same segment. So if here you have a 20, it means that even right here you have a 20 degrees. So what I've said is right here we are also going to have a 20 degrees. Why? Angles in the same segment. So this line AD, if it's a diameter, okay, if it's a diameter, it means it has formed this right angle, meaning that the angle which will be on this point right here is going to be a 90 degrees. So here we are going to have a 90 degrees, and here we are also going to have a 90 degrees. I hope you have seen there. Okay, so now if you are saying we are going to have a 90 degrees, right here, and here 90 degrees. So this line AD is a diameter because it's forming angles in a semicircle. So AD is a diameter because it's forming angles in a semicircle, okay, which is giving us a 90 degrees, as you can see right here, and here a 90 degrees. That's the answer for question A. So let us now look at the next question. So under question B, under this question B, they have said find angle ACF. Angle ACF. So the angle on C right here. This is very simple. I've said the angle which is on E and on the angle right here. These are angles in the same segment. So even here it's a 20 degrees. So angle ACF is equal to 20 degrees. Okay. Then we come to the other question. So the other question is this one. Find angle DEF. Angle DEF. DEF. So to find angle DEF, they just want you to find an angle which will be right here. Okay. So remember, here we have said you have a 90 degrees. So to find this angle, you just add. Okay. You just say 90 degrees plus a 20 degrees, and this will give you 0 plus 0, 0, 9 plus 2, it's 11. So this will give you 110. So DEF is 110 degrees. So these were the answers. And here on A, I've said AD is going to be a diameter because it's forming a right angle. It's forming an angle in a semicircle, which is a 90 degrees. Okay, that is the answer. So we have answered this question. Let us now move on to the other question. Alright guys, so I've come to question 18 right here. Question A, it is given that triangle PQR below is a right angled at R. QR is equal to 4 centimeter and tan QPR is equal to 4 over 3. Find sine PQR. So they want us to find sine PQR. So before we find sine PQR, we need to take note of the information that we are given. They have said tan QPR is equal to 4 over 3. So first thing, we know that when we are finding tan is equal to opposite over adjacent. This is the formula, not so? Because this is a right angle triangle, so we need to apply the SOHCAHTOA principles there. So tan is equal to opposite over adjacent. So the longest side of a right angle triangle, this longest side, this is the hypotenuse. So we label our sides, this is the hypotenuse. Okay, so if this is our hypotenuse, then tan QPR, tan QPR, the tan which was there. So definitely this will be the opposite and this will be the adjacent. Okay, this is how we can label the sides. Now, from here, they have told us that tan PQR is equal to 4 over 3, meaning that opposite is equal to 4, adjacent is equal to 3. So here where we have adjacent, you are going to put a what? A 3. Now they are saying we find sine PQR. So how do you find sine? So when you go to SOHCAHTOA, sine is found by opposite over hypotenuse. So when you look at this triangle right here, we don't have the hypotenuse, not so. So we need to find the hypotenuse by using the Pythagoras theorem, because we have the 4 right here and we have the 3 that side. So to find this hypotenuse, we are going to find the sum of the squares. Okay, we are going to find the sum of the squares of the opposite sides. So we are going to say PQ, that is where the hypotenuse is. We say PQ squared equal to, we are going to add 4 squared plus 3 squared. So this will give us 4 squared is 16 plus 3 squared, it's a 9. So this will give us a 25 when you add. Okay? When you add. So now, on this PQ, we need to get rid of this power 2, of which we introduce the square root. So this will be PQ equal to the square root of 25, it's a 5 centimeter. So on the hypotenuse here, we have a 5 centimeter. So now, we can complete our question right here. It says sine PQR equal to, so what is our opposite? Okay, what will be our opposite on sine PQ? Right here, sine PQ. So our opposite will be a 3. So 3 over, what will be our hypotenuse? It's a 5 that you have found. So let me just write it here. Sine PQR equal to, so we have said our opposite is a 3 over our hypotenuse is a 5. So this is our answer. So I hope that you have gotten what I've explained. So I have answered question A under question 18. Let us now move on to question B. Alright, so we come to question B. The question reads, the ratio of the surface areas of two cubes is 16 to 25. What is the volume of the smaller cube if the volume of the bigger cube is 500 centimeter cubed? So we have been given the surface area of the two cubes, and you have given one volume of the bigger cube. They want us to find the volume of the smaller cube. So first step, we are going to find the square root of the ratios, okay, so that we get back to the original ratios. So we are going to do this. We are going to write 16 to 25. So I've said first we find the square root so that we get back to the original values. So square root of 16, this will give us a 4. Square root of 25, this will give us a 5. So this is the area ratio of area ratios. Now, upon finding this, you want to find the volume of the smaller cube. So what we are going to do is, we are going to say 4 over 5. You can write a ratio as a fraction. We put it in brackets. Then we write to the power 3 because of the cube equal to, then we equate to the volumes of the cube. So the volume of the larger cube is 500. So the volume of the smaller cube, we just say x. So say x over 500, like this. So 4 power 3 means 4 times 4 times 4, which will give us a 600. So 4 power 3, sorry, a 64. This will be a 64 over 5 times 5 times 5. This will give us 125 equal to x over 500. Now from this stage, we are going to cross multiply. So when we cross multiply, we are going to have x times 125. This will be 125 x equal to 64 times 500. So upon doing that, since we want to find the value of x, we divide by 125. Even this side, we divide by 125. So when we divide with 125, you cancel this 125. We are going to have something like this. X equal to, so 125 into itself, it's 1. 125 into 500, it's 4. So we have remained with 64 times 4. So x equal to, remember this is paper 1, so don't use a calculator. So 4 times 4, it's a 16. We write a 6, we carry a 1. 4 times 6, this is a 24, plus 1, a 25. So centimeter cubed. So this means that the volume of the smaller cube, okay, volume of a smaller cube equal to, we have answered 256 cubed centimeter. Okay, this is our answer. So we have answered this question. Let us now move on to our question 19. We now come to our question 19a. The question reads, a businessman bought 300 company shares at 60 kwacha. The nominal price was 30 kwacha. How much does he pay for the shares? So we are looking at a businessman who bought 300 company shares at 60 kwacha, and the nominal price was 30 kwacha. How much does he pay for the shares? So this question, since this man bought 300 company shares at 60 kwacha, meaning that for 300 company shares, he paid the same 60 kwacha. Not the businessman bought 300 company shares at 60 kwacha. Yeah. The nominal price was 30 kwacha. How much does he pay for the shares? So looking at the question, the man paid 60 kwacha for the 300 company shares. According to the question, how much does he pay for the shares? He bought 300 company shares at 60 kwacha. So our answer here is going to be a 60 kwacha right here. He paid a 60 kwacha. Okay, this is our answer. We now come to question 19. So question 19b, this one. The equation of the straight line L is given by 2y minus 4x minus 5. Find the equation of the line passing through negative 2,3 and perpendicular to L. Find the equation of the line passing through negative 2,3 and perpendicular to line L. So here, first thing, we have line L. This line L is passing on 2y equal to 4x minus 5. So since we are saying these two lines are perpendicular, meaning that they are forming a 90 degrees, okay? Or when we multiply the gradient of line 1 and the gradient of line 2, it's giving us a negative 1. So if we have m1 times m2 is equal to negative 1, it means these lines are perpendicular. Okay, so let us find our m1, our gradient 1, using the same line, this one. So remember, we have the general form of the equation, which is y equal to mx plus c. So let us find the m, which is the gradient, by making this y the subject of formula so that it can look like this. Okay, so we have 2y is equal to 4x minus 5. So I'm just going to divide by 2, even this side by 2. So we're going to have y equal to, so when we separate, we have 4x over 2 minus 5 over 2. So y equal to 2 here 1, 2 here 2. So we have 2x minus 5 over 2. So you can see here the coefficient of x is m, which is gradient, and here the coefficient of x is 2. So this means that m1 gradient 1 is equal to 2. Okay, so this is our gradient 1. Now we need to find our gradient 2. So in this case, our m2, okay, our m2 is going to be negative 1 over a 2. Okay, so this will be our gradient 2. So we can use now our gradient 2 and the given points to find the equation of the line that is perpendicular to line what? L. So this is what you are going to do. So our M2 is negative 1 over 2. Then the given points are negative 2, 3. So what you do is you use this equation of the straight line y minus y1 equal to m open bracket x minus x1. So looking at these points that you have, this will be our x1, this will be our y1. So you just substitute y minus our y1 is a 3. Then m is this one, which is gradient 2. It's negative 1 over 2 open bracket x minus our x1, it's a minus as well, so this will be affected to be a positive 2. Now from there we can open the brackets by multiplying with negative 1 over 2. So y minus 3 is equal to negative 1 over 2 times x. This will be negative half x, negative negative positive. So these 2 and these 2 cancel. We just remain with a what? A 1. That is what we are going to have. Now from here we need to take negative 3 to the other side. So this will be y is equal to negative half x minus 1 then plus a 3, because 3 right here was a negative. When it goes this side becomes a positive. So we have y equal to negative 1 over 2x, negative 1 plus 3. This will be a positive 2. So this is our answer. This is the equation of the line that is passing through L and it's perpendicular. So this is how we can find the equation of the perpendicular line. So I hope you have gotten what I've explained. We have answered our question 19. We now move on to our next question, which is question 20. Alright, so we now come to question 20a. The question reads, the diagram below shows a cone with apex V and radius R. So this is the diagram that is showing a cone with apex V and the radius R. How many planes of symmetry has the cone? So they want us to find how many planes of symmetry as the cone. So the planes of symmetry, we are looking at the ways in which we can cut this cone, and we have identical shape. Okay, so when it comes to a cone, it has uncountable number of planes of symmetry, or it has many, or it has infinity. That can be your answer. So you just say many. Okay, so just write planes of symmetry, planes of symmetry for a cone is infinite, or you can say many, or you can say uncountable. So whatever way you choose to write this, they will mark you. So that is the answer. Let us now move on to our question B. Alright, so we come to our question 20b right here. The diagram below is an incomplete program flowchart to calculate the curved surface area of a cone with base radius R and slant height L. Complete the flowchart below by writing appropriate statements in the blank symbols. So we have our flowchart right here, as you can see, which is showing beginning. Then we have got those boxes and the end there. So they want us to write they want us to complete the flowchart below by writing appropriate statement in the blank spaces. So they are talking about an incomplete flowchart, which is calculating the curved surface area, okay, of a cone. So first thing, we need to come up with the formula that we can use to find the curved surface area of the cone. And this formula is S equal to, this is the formula for curved surface area of the cone, where we say pi times radius times L, which is the slant height. So here in our parallelogram shape, we are going to enter. Okay, so in this case, we are just going to enter R, then we also enter L. We are not going to enter the pi, so because it's already in the computer there. Then from here, we are going to write our formula in the rectangular box here, where we say curved surface area, okay, is equal to, so here we can say pi times, this is times pi times radius, okay, then times L. This is what you are going to write here. So this is our answer here, as simple as that, and it was just carrying 2 marks. Okay, so let us now move on to another question. All right, so we've come to our question 21. Write down the 4 inequalities that define the unshaded region R on the diagram below. So this is the diagram right here, which is showing the unshaded region R. Okay, so we have the 4 inequalities. We have this line, we also have this line, we also have this line, and this line. Okay, so they want us to write the 4 inequalities that are going to describe the unshaded region. So first thing you need to observe, we have this line, okay, then we also have this line. So this line is the simplest, and we also have another line right here. It's also the simplest. We also have this line. Okay, so this one we can work it out later. So we are going to name our lines. So you say this one will be our line 1, okay, then this one will be our line 2, then this one will be our line 3, then lastly this one will be our line 4. So when you look at line 1, this one, line 1, it's passing through the y-axis. This is the y-axis, at which point a 6, because we have 0, 2, 4, 6. It's passing on 6. And what type of a line is it? It's a solid what? A solid line. So if you have a solid line like this can either give you greater or equal to, or less or equal to. That is step 1. So under line 1, it's a solid line that we have. So the shaded part, okay, this shaded top part, you can see this shaded top part, it's greater than 6. Okay, so we want to describe the unshaded part here below, okay, for this line 1. So the unshaded part is less. Okay, so for line 1, we are going to write, we have said it's under y, not so, it's in the y-axis. So we are just going to write y, okay, we leave space, then we have said it's a 6. So since it's less, so use less than or equal to. This is for number 1. Why are we saying less than or equal to? Because the line is a solid line. But if it was a broken line, I wouldn't have included the equal to symbol on this less than sign. Okay, so we have answered for line 1. Let us now answer for line 2. So under line 2, you can see where is line 2 is right here. It's passing on this x-axis on the point where we have 0, 1. There is a 1 right here. There is a 1. So it's passing on 1 right here. Okay, this is the line passing on 1. Why am I saying 1? Because here you have a negative 2. So it's passing on negative 1 in the x-axis. So you are going to write x, you leave space, and then you write negative 1. Now, what inequality sign are we going to put here? So look at the line. The line is a dotted line. So since it's a dotted line, it's just going to be less than or we can write it as greater than, depending with the conditions. So the shaded part right here, because it's passing on -1, so this shaded part is less. Okay, this shaded part is less. Now they want us to describe the unshaded part behind it right here. So this unshaded part is greater than -1. So there we are going to write x greater than -1. So this is our line 2, this is our line 1. So for this one, we are not going to include greater than or equal to, no, because the line is dotted. Okay, so let us now move on to our line 3 right here. So this is our line 3. It's also passing in the x-axis. Okay, so under our line 3, it's also passing in the x-axis, at which point x is equal to f4. So f4. So what inequality sign are we going to put here? Remember, this is a solid line. So if it's a solid line, it's going to have this equal to sign as well. So the shaded part on this line 4, it's this side, which is greater. So we are going to describe the unshaded part here, which is less than. So we are going to say x is less than or equal to a 4. Okay, less than or equal to a what? A 4. Why? Because the line here, which is passing on 4, it's a solid line. That's why I've put less than or equal to. So we are just remaining now with our line 4. As you can see, we are just remaining with our line 4. So for this line 4, we can see where it's passing. So when it comes to this line, okay, it's cutting both the x-axis right here, and it's also cutting the y-axis right here. So first thing, you need to take note of the point. So it's passing on this -2. Okay, it's also passing on this +2 right here. So you can make these as your coordinates. So where it's passing, this is the line x equal to 0, this line right here. Okay, so the coordinates we have 0, comma, then I'll get a -2 like this. Okay, then the other coordinates, since it's passing on this +2 right here, and this line, this is the line y equal to 0. So it's passing on 2 right here, so I'll say 2, 0. So I can use the 2 coordinates now to find the gradient of this straight line. You find the gradient of this straight line. Okay, so I've gotten this -2, and this is the line x is equal to 0. So this is 0, -2, and it's also passing here on this +2. So this is the line y is equal to 0. So it will be 2, 0. Now upon writing that, we need to find the gradient, and we name our points x1, y1, x2, y2. So formula for gradient, how do we find the gradient? So to find the gradient, we are just going to say m, which is for gradient, is equal to y2 minus y1 over x2 minus x1. So m equal to y2, when you look here, it's a 0, minus y1 is a -2. So this will be a +2 because it will be affected by the negative. Then our x2, it's a 2 right here, so it's a 2 minus our x1, it's a 0. Okay, so m equal to 0 plus 2, it's a 2, over 2 minus 0, it's a 2. So m equal to what? 1, because 2 here 1, 2 here 1. 1 into 1, it's 1. So the gradient is equal to 1. Upon finding the gradient, we can now find the equation of the straight line by coming up with our formula. So formula will be y minus y1 equal to m, open bracket, x minus x1. So remember, we do have our coordinates, which is 0, 2, and we also have 2, 0. So from these two coordinates, you can pick any. In fact, you have 0, -2. This one should be a negative, and 2, 0. Okay, let's just check. Yeah, 2, 0. So in this case, you can pick any coordinate. So let's say I'll pick this one because I know that this will be x1, my y1 will be a 0, so that I simplify the calculations. So we are going to have y minus 0 equal to, so y1 is a 0, that's why I've put a 0 here. Our gradient, it's a 1, open bracket, x minus our x1, it's a 2, because we have used these coordinates. So y minus, so just say y is equal to, because y minus 0, this 0 won't change anything. So y is equal to 1 times x, it's x, 1 times -2, it's -2. Okay, this is the equation, but we need to come up with the inequality. So we say y, we leave space, then we write x minus 2. Upon doing this, we need to find what inequality we are going to write here. So we are going to go back to our diagram right here. So on this diagram, we need to describe the unshaded part. This is the line, this one. So the shaded side is this one. Okay, so this shaded side is the lower region, and the lower region is less. The unshaded part is the upper region. So I've said the unshaded part is the upper region. This is the unshaded part, the upper region. So this upper region, it's greater. Okay, the upper region is greater. Then what type of the line do we have? We have a dotted line. So there we're just going to say y is greater than. Okay, so we come back right here. So we have said we are just going to put the symbol y is greater than x minus 2 without the equal to, because the line is dotted. So this is how you can answer this question. Let us now move on to the next question. All right, so we now come to question 22a. If y is equal to, in brackets we have 1 minus 2x, another brackets we have 1 plus x minus 2. Find the values of x for which y is equal to negative x. So what we are going to do is, we are going to write the equation that we have, this one. So this equation, we are answering for a. So this equation is y equal to, we have 1 minus 2x. Then we also have 1 plus x, then minus a 2. So they have told us that y is equal to -2. So where there is y, right, you are going to put a -2. So this will be -2 equal to, then 1 minus 2x, again 1 plus x, then minus 2. So when we correct the like terms, we get this -2 to go there. We are going to have something like this. We have -2 plus 2, which is equal to 1 minus 2x, again 1 plus x. So these will cancel, it's a 0. Okay, these will give us a 0. So 0 equal to 1 minus 2x, then 1 plus x. So upon doing this, we now need to equate the first bracket to 0, again the second bracket to 0. So we are going to have 1 minus 2x is equal to 0. Okay, or we write this other one where we'll say 1 plus x, where we say 1 plus x is equal to 0. So here we can get this one to go where 0 is. We're going to have -2x is equal to -1, because this is a positive one. When it goes this side to be a -1, so it will be 0 minus 1, it will be a -1. The same thing will happen here. The 1 will go where 0 is, so it's a positive to be a negative. So we are going to have something like this, or x is equal to -1, because 0 minus 1 here, 0 minus 1 to be a -1. So we just need to work it out here, where we divide with -2, even this side -2. So this and this will cancel. We're going to have x is equal to negative, let me cancel. It's not going to be a negative, because the negatives will cancel right here, this negative and this negative. So we are going to get a positive value, which is a 1 over 2, or x is equal to -1. So these are the values. X is equal to half, or x is equal to -1. So these were the answers that we can write here. X is equal to 1 over 2, or x is equal to -1. So let us now answer question B. Alright, so we've come to question B right here. The question reads, the sketch shown below represents a section of the curve y is equal to x, in brackets we have x minus 2. So this is the section of the curve which is showing this curve right here, and this curve is y is equal to x, in brackets we have x minus 2 right here. So let us now look at the question. So this is the question right here. Question 1, find the coordinates of the points where the curve cuts the x-axis. So this is the x-axis. They want us to find the coordinates of the origin right here and the points here, because this curve is cutting the x-axis on point O and point A. So one thing we must know is, before we even find these coordinates, this is the x-axis, but it's the line y is equal to 0. So meaning that these coordinates, the O coordinate, or we say the origin, okay, it's going to be a value for x, 0 for y. Then even this a coordinates is going to be the value for x, 0, because I've said this is the line y is equal to 0. So what we are going to do is, we are going to look at the function of this curve. It's this, y is equal to x, in brackets x minus 2. So we are going to write our function, which is y equal to x, open bracket, x minus 2. So this is the line y is equal to 0. So where there is y, you put a 0 equal to x, open bracket, x minus 2. So you equate x equal to 0, or x minus 2 equal to 0. So this one is already solved. Let's just solve this one. So this -2 go where 0 is. We have x equal to 0 plus 2. So x equal to 2. So for this 0, it's here on the origin right here, which is passing on 0, 0. Then for this 2, it will be right here on the coordinates for A. So these are the coordinates. The origin is 0, 0. Then point A is 2, 0. We have answered this question. Let us now look at question 2. So this is our question 2 right here. What is the minimum value of the function? Okay, so to find the minimum value of the function, first let us go back to our curve. This is our curve. Now, in this curve, we have been given this this equation for the function, or for the curve. This equation for the curve, which is y is equal to x. In brackets, we have x minus 2. So let us try to use the same. So here we are going to write, we have y equal to x, open bracket, x minus a 2. So let us try to expand. You have y equal to x times x, it's x squared minus 2x. So from here, since we want to find the minimum value of the function, we can start by first, let us find the x coordinate. So to find the x coordinate, we use this simple formula: x is equal to negative b over 2a. So if you have this function, a will be presented by the coefficient of x squared, then b will be presented by the coefficient of x. So our a in this case will be a 1 because the coefficient of x squared is a 1, and our b will be the coefficient of x, it's a negative 2. So we just substitute x equal to, so here we are going to have negative, in brackets we put negative 2 over 2. The value of a, it's a 1. So from there, what are we going to do? From here, we are just going to say x equal to this negative and this negative out. So it's 2 over 2, because 2 times 1 is a 2. So x is equal to 1, because 2 into 2 it's a 1. Now we can substitute. We can substitute a 1 into this function. So we are going to write y equal to, where there is this x, we are going to put 1. So we say 1 squared minus 2 open bracket 1. So y equal to 1 squared, it's 1, minus 2 times 1, it's a 2. So y is equal to 1 minus 2. This will be a negative 1. So this is this will be our minimum value for the function. So when you take a look at this will be our minimum value, because even when you take a look at this function, it was making a 10 here. Okay, so we have answered this question. Let us now move on to our second question. We now move on to our second question. So we just write our answers. So here we say the coordinates of a will be a 2, 0. Then here the minimum value, we have said y is equal to negative 1. So we go to our last question, which is question 23. Alright guys, so we have come to our question 23 right here. The diagram below shows a speed time graph of a car journey. So this is the speed time graph. So here in the y-axis, we have speed that is measured in meters per second. And in our x-axis right here, we have the time that is measured in seconds. Our question A, find the acceleration during the first 5 seconds. So the first 5 seconds it's here. So the acceleration you are looking at from this point going up on the speed of 30. Then the time is what? A 5. So we are going to start with our formula. So A, we say acceleration is equal to final velocity minus initial velocity over time. So acceleration is equal to, the final velocity is here, okay, where we have a 30. So 30 minus the initial velocity is here, a 0, over our time. They have said in the first 5 seconds. So over 5. Acceleration is equal to 30 minus 0, it's a 30 over a 5. So acceleration is equal to 5 here, it's a 1. 5 into 30, it's a 6. And 1 into 6 will get 6. Then just write meters per second square. These are the units for acceleration. So we have found the value of acceleration. So we have answered our first question. We now move on to our question B. Alright, so we have answered our question A. We come to question B. If the total distance traveled was 825 meters, find the value of t. So if the total distance that was covered from 0 seconds up to t seconds okay, was 825. What is the value of t? So to find the value of t, first let us look at this shape right here. You can see this is a trapezium, okay? So distance under the graph is the same as area. So we are going to consider using the formula for finding the area of a trapezium. So how are we going to use this formula? This is what we are going to do. So the formula for finding the area of the trapezium, we have said you have not use it in form of distance, where I will say distance is equal to, so A plus B, then here times H over a 2. So A is here, then the B is here, meaning looking at this distance up to this is the B. Then the height, it's right here, meaning from here up to here. So A is equal to the difference here between this distance. We have a 15 here and a 5. So it's 15 minus 5, which will give us a 10. That is the value of A. Then for B, we will do the same. Here we have a t, so it's t minus, the first is 0. So t minus 0, it's a t. So the B is equal to t. H is the height, which is equal to, from here up to here, 30 minus 0. So it's a 30. So we are just going to substitute. We say for D, we have been given that the total distance is 825. So let us substitute. Where there is D, we are going to put 825 equal to, where there is A, we are going to put a 10 plus, where there is B, we are going to put a T, then times, where there is height, we are going to put a 30 over a 2. So I hope that this part is clear. Okay, so from here we are just going to say 2 here, 1, 2 into 30, it's a 15. So we are going to have 825 is equal to, so we have 10 plus t, then we have a 15 right here. So we say 825 equal to, so we need to open the brackets right here by multiplying with a 15. So when we multiply with a 15, you say 10 times 15, you got 150, plus 15 times t, you get 15t. So we can let the 150 go this side. So we have 825 minus a 150, which will be equal to a 15t. So this is paper 1. There will be no need for you to use a calculator. So when you have 825 minus 150, this will give us 5 minus 0, it's a 5. 2 minus 5, it can't, you borrow a 1 from 8, you remain with a 7. We have put a 1 there, we have 12. 12 minus 5. 12 minus 5, it's a 7. 7 minus 1, it's a 6. So here we are going to have 675, not 25. 675. So 675 equal to a 15t. So you need to find the value of t, meaning that we need to divide both sides by a 15. So what you are going to do is, you will cancel this 15 and this 15. So we have t equal to, so from here we can see, we can try to reduce. We find the number that can go into 15 and 675. So let's say we get a 5. Okay, so if we get a 5, we are going to have something like this. We are going to say 5 into 15, it's a 3. 5 into 6, it's a 1. Remainder 1. 5 into this 17, here it's a 1. 5 into 17, it's a 3. Remainder a 2. 5 into 25, it's a 5. Then here we have a 3. So I hope you have seen what I've done here. Okay, so I've just said 5 into 15, it's a 3, which is down here. Then 5 into 6, it's 1, remainder a 1. So the one I put it on top of 7, we have 17. 5 into 17, because there are 3 times, because 3 times 5 is 15. So the remainder will be a 2, this, which is this one. So this 2 and the 5, you have a 25. 5 into 25, it's a 5. Now from there, we can say t is equal to, so what we need to do is we say 3a1, 3 into 13, because there are many times 4, not a 6, sorry for that. It's a 4, because 4 times 3 to give us a 12. So 3 into 13, it's a 4, remainder a 1. So this 1 and the 5 are 15. 3 into 15, it's a 5. So we are finding t, which is time, so which is 45 seconds. So this is our answer, as simple as that. Okay, so we have answered our question B right here. We just need now to answer our last question, which is question C. All right, so we now come to question C, which is our last question under this paper. Find the average speed for the whole journey. So to find the average speed for the whole journey, we need to come up with the formula that we can use to find the average speed. So average speed is equal to total distance over total time taken. So average speed is equal to, now our total distance, they told us that here the total distance for the whole journey is 825 over what is our total time. Our total time, we have just found that it's a 40. Okay, it was 45 seconds. That is what we have. So average speed is equal to, I'll use a 5, where I'll say 5 into 45, it's a 9. 5 into 8, it's 1. Remainder a 3. 5 into 32, we have a 6. Remainder a 2. Then 5 into 25, we have a 5. So we have 169 over, 165 over a 9. All right, so from here we can leave this answer as a mixed fraction. Okay, so we are just going to say average speed is equal to, so we can say 9, we can try to say 9 into 165. Okay, 9 into 165, I think it goes there 18 times. Okay, because if you multiply, we say 18 times 9. Okay, 9 times 8 is 72. We write a 2, we carry a 7. 9 times 1 is 9 plus that 7. We are going to have a 16. So 162. So now we have 165. So we just say 165 minus 162, so that we know the remainder. 5 minus 2, it's a 3. 6 minus 6, 0, 1 minus, yeah. So from here, the remainder will be a 3. So we are going to write 3 over 9. So average speed is equal to 18 or number. So 3 here, it's a 1. 3 into 9, it's a 3. So this was speed, yeah? So just say meters per second. So we can write now on the final answer here that speed, we have found the value to be 18 whole number, then 1 over 3 meters per second. So thank you so much, everybody. We've come to the end of our lesson. So make sure that if you have any question or anywhere where I've made a mistake, you are free to comment in the comment section, and I will be very much happy to respond to your comment. So thank you so much, everybody. Once again, this has been your presenter, Mr. Mlenga. Bye bye.